All right, so again, this is page 369 and 370 that I'm going to be going over. So again, the first question, they give us some information. They tell us that this is 42 degrees. Now, the next thing they ask for is the arc. That is SR. So that is also 42 because you have, that was a central angle. So the arc and the central angle have the same measure. Again, anytime we're talking about measure of an arc, it's always going to be in degrees. Later on, we'll talk about lengths of arcs, and it'll be in things other than degrees. But again, if it says measure of an arc, it's always in degrees. Now, on part B, measure of angle SCQ. So SCQ. Well, SCQ and SCR, those two angles together are... They add up to 180. They're a linear pair, which means that they have to be supplementary. They add up to 180. So 180 minus 42 is going to give us 138. Now, for C, they say SQR. They're going from S through Q all the way around to R. Well, it's more than a semicircle. It's going from S all the way around to R. The only thing that's not being included here is this little piece. So an easy way to do C here would be to do 360 minus 42, which gives us 318. All right. Now, for D, they look at the measure of arc QV. So here's QV. It should be the same as the other side, so that should be 42. Again, you had vertical angles. These two are congruent, so then the arcs are congruent. Measure of angle QSV. Now, QSV, notice there's no line there. You'd have to draw in your own line to do this one. So if I drew in a line that went from Q to S and then over to V, we're talking about this angle. This angle is intercepting this little arc. Right? But again, it's on the circle, it's intercepting the arc, it's half of the intercepted arc. So it is 21. It's, again, when we talk about an intercepted arc is an arc that's on the inside of that angle. So here, this is our angle, right? So this is the piece of the arc that's on the inside, the interior of the angle. Again, that's the intercepted arc. All right. So we took, those are the two endpoints that we're using from that arc. This was 42, so that intercepted arc is double the angle, or the angle's half of the arc. Yeah, and again, this goes back to what I was just talking about before, right? If it's on the circle, it's half the arc, right? So now, for F, angle QVR. Well, QVR. Wait, QVR. Yeah, sorry. QVR. This angle. Do what? It's 90. I heard 90. Who said 90? Yeah. All right. So why is it 90? Why is it 90? You're right. Why though? Give me a reason. All right. I need more. What did you say? All right. Shh. Okay, guys, hold on. Guys in the back, you guys are getting too loud there. Again, on here, this angle is inscribed into a semicircle. The ends of the angle are the endpoints of the diameter. So it's going to always be half of this 180 degree arc, right? This is a semicircle. So it's going to be half of it. Anytime you have an angle inscribed into a semicircle, it will always be 90 degrees. Again, that's one of our properties. And again, I included it in this section as well because anytime you have a circle and an angle is inscribed into the other half, it's got to be half of that intercepted arc. So it's always going to be 90, no matter what. All right. On number 2. use the fact that LCR is 90 degrees. So LCR, this is 90. So there's a few different things they want us to answer there. The first one is, if CQ is an angle bisector, what is LCQ? So each of these would have to be 45. So that's 45 degrees. Identify two major arcs. Now, is there more than two major arcs here? Yeah, there's a lot of major arcs. Anything that's greater than 180 but less than 360 is a major arc. So let's say I start with K. Can somebody give me a major arc that starts with K? KPR. So if I went around that way, that'd be more than 180. Hold on 1 second. All right. So KPR. Now, could I get another major arc that also starts with K? Say again? KPQ. That would also work. Is there another arc that starts with K that is also a major arc? KLP. You're starting to get the idea. There are many different arcs that we could have done here. We just used K to start off each one, and we already have 3. But there's even more than that. There's probably at least 5 here that could start with K. And then we could go on to the next letter and do even more. Any arc that is more than 180 degrees but less than 360 is a major arc. Now, also being said there, you have to make sure you use 3 letters. The 2 on the ends are the endpoints of the arc. The one in the middle shows the direction that you're going around the circle. So in each case, the 2 on the ends are the endpoints of our arc, and the one in the middle is the direction we're going around the circle. All right. On C, name 2 congruent minor arcs. Which 2 arcs would have to be congruent? All right, you said 3. Now, remember, we can't assume anything, right? So, it looks like these 3 are congruent. Do we know all 3 of those are congruent? The only 2 we know are congruent are these 2. Okay, hold on. Yeah, so there is another set. Hold on to that thought. So, out of these smaller ones, there's only 2, right? And again, they wanted 2 congruent minor arcs. So we know that since it said earlier this is a bisector, right? It said this is a bisector. We know that both of these are 45. So both of these are also 45. So we could say LQ is congruent with QR or RQ, however you want to phrase that. There is one other set that you can say as minor arcs are also congruent. And it's the 2 that are both what? So we did the 2 that are 45 degrees. What other measure arc do we have that's congruent in this? What'd you say? PR and RL. Those are both 90 degrees, right? So we could also do those 2. So PR and LR also work. So again, there are 2 different sets that you can do there. The one that is there purposely to throw you off, though, is KL. KL, we don't have any information to say that's congruent with these 2. So don't fall for that trap. Again, you have to make sure you have the information in order to do that. You can't assume anything. All right. Hey, guys in the back. You need to be paying attention or you need to get out because there's a lot of people here. I know, but there's a lot of people in that group that are not paying attention. And this is tutoring, and lots of people want to learn. Yes? These are arc symbols. The one in the middle is a congruent symbol. Yeah, that was just a not very nice arc. There you go. Okay. On D, name 3 adjacent arcs that form a semicircle. LQ, you said QR, and PR or RP, either way. Yep. So these three here form a semicircle. All right, together they add up to 180 degrees. Good. All right, on the next one. So now we have a new circle. This is circle O. They told us that BE is perpendicular to IS. So segment BE perpendicular to IS. So I'm going to draw a 90-degree angle there so we know that. They also told us at the beginning, measure of angle TOE is 36 degrees. TOE is 36 degrees. So now, first thing I should know from that one is if I know that angle, which is a central angle, the arc that it intercepts is also 36 degrees. And again, that's our first question. That gives us the answer to A. Now, the next one they ask for is ST. Well, if this whole thing from S to E is 90, I can subtract the 36, and this piece would have to be... All right. So now, because these two they said are perpendicular, right? So then this side is also perpendicular, right? So that's a 90. So this is a central angle. So this piece would also have to be 90, because again, the arc and the central angle must be the same. All right. The next piece that we know, or that we need to know, is SIT. So measure of angle SIT. Well, SIT is a inscribed angle. It's on the circle and intercepts the arc that is 54. So in order to get SIT, I'd have to take the 54 and divide it by 2, which is 27. So again, this angle is on the circle, right? Again, an inscribed angle is half of the intercepted arc. All right? So then, measure of SB. Well, SB is what? 90. Yeah, because the angle, the central angle is 90, so the arc it intercepts is the same. All right? BIS. So angle BIS. Well, careful. BIS 45. Half, right? This one now is an inscribed angle. It is on the circle. Any angle on the circle is half its intercepted arc. So we had to do the 90 divided by 2. All right. Angle IOT. So IOT. Well, IOE is 90. So 90 plus this 36 would be what? 126. Good. Measure of arc IT. Well, IT is the arc that is intercepted by this same angle we just found in F. Right? So that would be what? 126 as well. Because again, if that angle is 126, the arc is 126. Or again, you can figure out the same way we just did the last one. This is 90. 90 plus 36 is 126. The final one there, TBI. So TBI. So this angle here. So it's going to be half of what? Half of the 126. So 63. Again, we did 126 divided by 2 to get 63. Any other questions there? To get F, we added, so this was 90, and this was 36, so we added 90 and a 36 to get. So we actually went way back to like chapter, I think that's 3, and did angle addition postulate. Right? We added the two angles together to make the bigger angle. In this section, we had arc addition postulate. Again, you could use the arc addition postulate if you want to do TI, because this is 90, that's 36. You could say that's 126 because of arc addition. All right, let's go on to the next one. On number 4, what is the value x? Now, this angle is what compared to that arc? Half. So we need to write an equation in order to solve on this one. So we're using some algebra here. So the angle is half of the arc. So we're doing the arc divided by 2. Right? That was our equation before. Right? And here, I'll write it above in case. Sorry. So again, we did the angle is half of the intercepted arc. So, first step I would make these numbers smaller. You could choose to get rid of the 2 by multiplying it to the other side. I would just go ahead and divide this from this side. We can divide both those by 2. 10x minus 5 equals 8x plus 11. Combine your like terms. We got to bring the x's over to one side and the constants over to the other. So I'm going to bring the 8x this way by subtracting it. So 10x minus 8x is, and then we're going to bring the 5 over the other way. So add the 5 to the other side and you get, so then divide by 2 and x is, and that's our answer. And if you want to double check it, this was a multiple choice question. You could have taken your answers and plugged them in. And when you plug them in, you should get a value for this angle that's half of this value. All right. So again, you could double check them by doing that as well. All right. Number 5. Use the circle below to complete the following. So here it says, if these two arcs are congruent, then arc AB is congruent to. So if these two are congruent, what else is congruent? The two arcs that they intercept. So AB is congruent to BC. And that was that property that I remembered to go over with you guys today. So I forgot about that one earlier on. But again, it's a pretty easy concept, right? All right. On B. Write a convincing argument that supports your response to part A. Hint, draw AC or the 3 radii that contain points A, B, and C. So on here, again, they give you the hint that you could draw this and you could draw this. So you can see that, hey, on here, you would end up having congruent triangles, which end up being a perpendicular line, your right angles. You could say that these are then 90 degrees and say that these are also 90 degrees. Again, that's, so you could write something along those lines. I'm not going to write this out. There's several different ways you could explain that, but that's a simple one. You could draw in the diameter, you could draw in the right angle, the other radius, show that you have 2 congruent triangles, making those 2 right triangles since that's the diameter, and go from there. All right, moving on to number 6. If a polygon is inscribed into a circle, then each of its vertices lie on the circle. Which of the following correctly depict an inscribed polygon? So, this should be a very easy question. Which one's inscribed into the circle? A. It's the only one that has all the vertices on the circle. The other ones are not inscribed into the circle. Right? This one, a vertex is not touching the circle. This one, a vertex is outside the circle. This one isn't even a triangle. I hope no one picked D. Alright? Again, A is the only one that makes any sense at all. So, moving on. Yeah, springboard. They're like really hard questions, and they throw something like that on there. I don't know. All right. Shh. Yeah, let's get back to this. Shh. All right. On 7, find the length of one side of a square inscribed in a circle that has a radius of 4 centimeters. So, on here, if I was to draw a circle, I'm going to draw it up here. The radius is 4 centimeters. What would that make the diameter? 8. So, all the way across is 8. Now, I'm going to use that to help with my square. Everybody see the square? So, we know this distance is 8. Now we're going back to our trig from last chapter on this one. We know that's 8. And this diameter is splitting this into what type of triangles? What type of right triangles? Isosceles right triangles. Right? And if these are x, this is x times square root of 2. Right? So hey, this is 8. We need to go backwards. We need to divide by square root of 2. If you divide by square root of 2, you end up dividing by 2 and multiplying by the same radical. So 8 divided by 2 is 4. This would be 4 radical 2. All right, again, if you want me to show the work, so to go backwards, we'd be dividing by square root of 2. You have to rationalize your denominator by multiplying by the same radical. Say again? Hey, guys, again, you can leave. You don't have to be here. If you're not paying any attention to me, I don't know why you're coming to tutoring. They're trying to learn, and they can't hear me. If they're here spending their time at tutoring, they shouldn't have to go back and watch this video. If all you're here for is to get the answers and to watch the video later, then you don't have to be here at all. You can do that from home. I'm posting everything. If you don't want to waste your time, that's your own prerogative. You can leave. Again, don't waste their time. All right. So, on here, we had 8 divided by the square root of 2 because we're going backwards. Now, in order to rationalize, again, you multiply by the same radical that's on the bottom. So we multiply by radical 2 on both the bottom and the top. And then once you do that, the top becomes 8 radical 2. The bottom is just 2. So then 8 divided by 2 is 4. So we have 4 radical 2. Again, the pattern that always emerges, anytime you divide by a square root, you're going to end up dividing by the number underneath the radical and then multiplying by the same radical. Right? Because that's essentially what ends up happening since you have to rationalize every single time. All right. Okay, number 8. Use the diagram to answer each of the following. So, there's 2 questions there. And they give you different values each time. So, I'm going to use 2 different colors to label this because on the first one they say A is 120. They say C is 84. And they say D is 108. Then, how much greater is measure of angle 1 than measure of angle 2? Well, in order to answer that question, you would first have to figure out this last arc at the top. So what am I going to do with these 3 measurements? Add them all up. If we add them all up, what do you get? 312? All right, so we get 312. We got to subtract that from 360 to get the remaining piece. So 360 minus 12, sorry, 360 minus 112 is 48. So this piece up here is 48. Again, we did 360 minus all of those values added together, which you guys told me was 312. I'm not double checking your work. I don't have a calculator here, so I'm hoping you tell me the correct things. Now, if that's 48, well, we can find angle 2 now, because if that's 48, angle 2 is what compared to that at the top? Half. So angle 2 would be 24. Angle 1 would be 120, because it's a central angle. Ooh, no, that's not a central angle. I lied. That's not a central angle. I lied. How do we know that's not a central angle? It's not in the center. At first glance, I thought it was in the center, but I know for sure it's not in the center because these two sides aren't the same measure. So it can't be in the center. If it was in the center, these two would have to be the same, right? So we have to use another property. Angle 1, measure of angle 1, can be found by doing these two, add together, and divide by 2. So the sum, 2 intercepted arcs, divided by 2. So measure of angle 1. This is going to give us 204. 204 divided by 2 is 102. So the question here was they wanted to know how much greater is angle 1 than 102. So my final answer, I got to find the difference between 1 and 2. So 102 minus 24 is 96. Right? Oh. Whoops, sorry. I wrote the wrong thing. My bad. I said 102 and I wrote 120. My bad. I was like, how'd you get 78? Yeah, 78. 78 sounds good.
Can you explain how you got 102 again?
Yeah, can you explain why we did that?
All right. So, okay. So, again, it's 102 there because we have the 120 from this side and the 84 from this side. This angle is in the center of the, sorry, not the center. This is in the interior of the circle. For the interior of a circle, you would have to do the average of the two intercepted arcs, right? That goes back to this formula right here, right? To find x, you have to average the two arcs, sum and divide by 2. So that's what we did here. We did the sum, divide by 2, and that's what gave us the 102. Now, so are you guys good with that? Do you need me to go any further? All right. Okay, so now the other one. They changed all of our measurements. So, using a different color. A, they now say is 110. Angle 1, they now say is 88. They want to know what C is and what B plus D would be. So, we don't have to rewrite on every single one of these, but if this is 88, the other side is also 88. Now, we're using the same formula that we did over here in order to solve for C. 88 is what we are saying it equal to, though. We already have the angle measure. So, 88, let me move this over. 88 is equal to the first angle is 110, plus the second angle we don't know, it's C, divided by 2. So now, solving this, multiply by 2, you get 176, right? Again, we knew C for part A. We don't know C for part B. They're totally different numbers.
I get that. I thought once you're like vertical and you put 88, I thought the angle was the same as the arc.
Only if they're central angles, right? Again, the angle would have to be on the center of the circle. You remember? So, right, this was 110, this is 88. Those aren't the same, right? If those aren't the same, we know it's not in the center.
I see. That would have been easier.
Yeah. So, we have to use this formula. So again, we multiply by 2. And now subtract the 110, and you're left with 66 for C, right? And then finally, for B and D, Well, we don't have to find them individually, right? It's not asking us to find them individually. So all we need to do is take the two values we just found, add them up, and subtract them from 360, and we'd have the remaining two arcs. So again, we don't have to do any extra work. Make it easy on yourself. Add those two up. Those two together is 176. So subtract that from 360. 184, you said? Again, you don't need the measures individually. You just need them together. Could you find them individually if you really wanted to? Probably, but we're not going to get into that. All right.
So is that degrees or?
Yes, this is degrees. My degrees there too. All right, on 9. Use always, sometimes, or never to make each of the following statements true. A parallelogram inscribed in a circle is a rectangle.
Not necessarily. Sometimes.
A parallelogram inscribed in a circle is a rectangle. All right, let's think about it. So, let's think about some properties of a parallelogram. What do you know about the opposite angles in a parallelogram?
Are they perpendicular? Yeah.
Opposite angles are congruent in a parallelogram. All right, so now take something you know about a circle. Shh, guys. Again, in a parallelogram, so first, our property of a parallelogram. Opposite angles in a parallelogram are congruent, right? Go to a circle. When a quadrilateral is inscribed into a circle, opposite angles are supplementary. So, if the angles have to both be congruent and supplementary, what does that mean each of those angles is? The same. They're both 90. So, in this case, it will always be a rectangle. Yeah, I can draw it. So, if, shh, guys, listen, watch. Here, I'll draw a circle for A. So this is for A. All right. I'm going to go ahead and draw a rectangle here, because it is going to end up being a rectangle. Now, knowing our properties of a parallelogram, the opposite angles have to be congruent, right? If these two angles also have to be supplementary, meaning they add up to 180. Well, 180 divided by 2 is 90. So now, they're actually right angles. What's our definition of a rectangle? Quadrilateral with all right angles. Again, we could do the same thing with the other two as well, right? And they would also be right angles. So, since this is a rectangle, again, it's the only way for this to happen. You cannot have a parallelogram in a circle without it being a rectangle. All right. On B, an inscribed angle that intercepts an arc whose measure is greater than 180 is acute. So again, let me say it one more time. An inscribed angle that intercepts an arc whose measure is greater than 180 is acute. All right. What would happen if your arc was greater than 180 and you divided by 2?
It would be over 90.
It'd be over 90. So it's not acute. It would have to be obtuse. So this one is never true. Yeah. So again, if you did 180, so if it had said 180 and divided by 2, then it would have been right. If it was less than 180, anything less than 180 divided by 2 would give you something less than 90, and therefore it would be acute. But anything greater than 180 divided by 2 would have to be greater than 90, and it would have to be obtuse. All right, on C. If two angles intercept the same arc, they are congruent.
I think that is true. They're going to the exact same arc.
This is one of those tricky questions.
Sometimes.
There is a property that I had you guys write on your notes that is almost exactly like this, but it's missing a word. What word is missing from this to make that true? Actually, you could do one of two different words. So, the property we had was two inscribed angles intercepting the same arc would be congruent. Right? Does it say anything about inscribed angles? No. I could also input the word central. Well, no, I couldn't have two central angles. Now, I think inscribed is the only thing that works there. So, if you drew, to show you a counterexample of this as to why it doesn't have to work, you could draw a central angle, and you could draw an inscribed angle, both intercepting that same arc. Are those two angles congruent? No. One of those angles is half of the other. So they are not congruent. Again, could this happen though? Yes. If you had two inscribed angles intercepting the same arc. That's the property that allows them to be congruent. All right. Number 10. 10 through 13. So, on this one, if measure of angle MPQ is 48. So, MPQ. If that whole thing is 48, find QM. So now, I'm going to go ahead and highlight this in orange so that you can see which one I'm doing. All right. So they said this is 48. They want us to find this length here, MQ. I'm going to call that X. Well, in order to find that piece, now I'm just wondering, have you done these with Miss Oswalt yet? Okay, because there's two different ways you can do these problems when you have two tangents. All right, so I'm going to show you with the formula, all right? And then I'm also going to explain the other method just in case she does it the other way. So, on here, this is X. This other side, well, the whole circle is 360, right? So this other side would be 360 minus X. So now, our equation would be 48 equals the big arc, which is 360 minus X, minus X divided by 2. Now, the nice thing about the equation is this works no matter what type of lines you have intersecting on the outside of a circle. So on here, the fact that it's two tangents doesn't matter. Now, we have this equation to solve. We can bring the 2 over by multiplying it to the other side, which will give us 96. We can go ahead and combine our two like terms, these two x values. That give us negative 2x. We can bring the 360 over, which will give us 264. And that's a negative 264. Oops, sorry, that is an x, not a 0. Divide by negative 2, and x is 132. So 132 is the measure of the arc we're trying to find. The other method for this, now, this only works if they're tangents. So it only works for a diagram specifically like this one. If you had anything other than two tangents, so say you had a tangent and a secant, then you need to use your formula. But if you have two tangents, there is one other method that we could use to solve for this. And it's going back to our properties of tangents and then also of quadrilaterals. So on here, I'm going to draw that image again real fast. So let me just do my best to draw that. All right. If I was to draw in my two radii to those points of tangency, we'd have right angles. Now, this is 48. Now, this method is nice and quick. All right? Again, the reason why I like the other one, this one, is because it works for any exterior angle. But with tangents, again, this is the other option. we have this angle is 48. We know that these are right angles. And now it's really easy. This angle that we're missing up here would be the same as this arc. We just have to subtract these angles from 360. So we'd have 360 minus the two 90-degree angles and the 48-degree angle, which would also leave us with 132. Because a quadrilateral, inside a quadrilateral, all the angles have to add up to what? 360. So again, we had 3 of the angles, so we subtracted, oops, sorry, let me move this over. We're going to subtract 3 of the angles that we know from 360, and it leaves us with the 132.
And how do we know that 48 is the same as the x again?
48 is not the same as x. This angle, and the arc are the same because this is a central angle. All right. So if we now found this is 132, the arc would have to be 132. Again, only works if you have two tangents. For this one? Me. Yep. All right. Number 11. It says if the measure of M and Q, so now I'm going to use blue, is 200. Then what is MPQ? Well, if this is 200, and this arc over here then is the remaining part of the circle, this would be 160. So for the angle, so now this would be the angle we're looking for. So x equals 200 minus 160 divided by 2. Again, it's the same formula again. 200 minus 160 is 40. 40 divided by 2 is 20. And that would be our angle. Number 12. If QN is 125. So QN, this piece here, is 125. And QR is 83. Find measure of angle 1. Now, notice, this is a tangent and a secant. Again, we have to use our formula once again. This angle is intercepting those two arcs that they gave us. This is the bigger arc, that's the smaller arc. So once again, it's the same equation. X equals 125 minus 83 divided by 2. 125 minus 83, that gives us 42. 42 divided by 2 is 21. And finally, the last one. If measure of arc NQR, so this whole thing is 260. So from N through Q all the way around to R is 260. And angle 1 is 45. Then what is QN? So I'm going to call QN X on this version of the problem. So I know this is getting very busy looking at this. In fact, I think it's so busy, I think I'm just going to white some of this stuff out so that you're not getting them all mixed up. Alright, so again, this piece here, 260. NQ is what we're trying to solve for. That's that piece out there. They told us that angle 1 is 45. Again, we have one other piece that we need to use in the formula. This piece is going to be the 260 that they gave us minus the x. So this is 260 minus x for the little arc. So on this one we have Let me see where I got some room. I'll just do it down here. We have the angle, which was 45, equal to the big arc, which we're calling x, minus the little arc, which is going to be the 260 minus x over 2. This one's a little more challenging just because of the way it's set up. So we have the 2. We can go ahead and multiply it to the other side. That gives us 90. But on top, we have to be careful here because we have a negative out here. Right? We're subtracting this. So we need to distribute the negative to all of this. We're subtracting this value, so I'm going to change that to a positive and distribute the negative. So this becomes negative 260 and positive x. So now if we combine like terms, both our x's are positive, so it's positive 2x minus 260. So we had a negative out in front, right? So on here, since we had a negative out in front, that negative applies to everything in those parentheses. So I had to distribute the negative to the 260 and the x. When I distributed, I went ahead and changed it to a plus sign now, because now the negative is on both of those individually. Then I can go ahead and combine like terms. So I combine the x and the x gives me 2x, and I have negative 260. So now, well, not minus, add 260. Add 260, and you get 350 equals 2x. Divide by 2, and that's 175.
175.
So that's our missing arc.
So with this piece, we have to use the last thing that we learned on the thing.
Well, for 25-4, that is all about the exterior angle. Yeah. Yeah, it was broken down. That was the last section. So, again, those are all of the questions I had you guys do. I did not have you guys do number 14. If you have questions on number 14, I can do them for you. All right, I'm going to stop this recording, though.